Alright, let's find the column and null space of this matrix A. I already put it in reduced row echelon form, so that should save some time. The column space is simply the span of the columns of the matrix. However, we want a linearly independent set of vectors as our basis for the column space. And that's why we need reduced row echelon form, because that tells us that because the first two columns contain leading entries, that we need to use the first two columns of our matrix as our basis. And that's all it is. It's not too fancy or anything, not too complicated. So 2, 3, and 0, -3 is a basis for our column space. Now, null space, that takes a little bit more work and is kind of tricky for lots of students. So I'll try to explain it as simply as possible so you can understand it the best. So the first step, which I already did, was to put the matrix into reduced row echelon form. Now, in order to find the null space, you need to set AX equal to 0. And pretty much all you're doing is solving that, but it can be a little tricky. So how do you do that? We know that this is the same thing as A times x1, x2, x3, x4. Sorry for the messy writing, by the way. And then that will equal zeros all the way down. I'm trying to write small so I can fit everything in this tiny space. So we can multiply our reduced matrix by this x vector to kind of expand everything out, to make it not more organized, but kind of more understandable, I guess. So we're going to say x1 plus 0 x2 plus 1/2 x3 minus 2 x4 equals 0. Because remember, it equals this 0 vector here. And our next row, we have 1 x2 plus 1/2 x3 minus, that's supposed to be 7/3 x4 equals 0. And now, since x1 and x2 are bound variables, we're going to move all of the other ones to the right side and isolate those variables on the left side. So we're going to have x1 equals, and x2 equals, and then since x3 and x4 are free variables, we're going to give them parametric variables because that's what's normally used, but you can technically plug in any value for those. They're free variables, but in order to find the null space, it's important to use variables to substitute. So we're going to use s and t, those are the most common. So x1 is -1/2 s, since x3 we're plugging in for s, plugging in s for x3, and then plus 2t, since x4 is t. Then for x2, move everything to the other side, we get -1/2 x3 plus 7/3, whoops, sorry, forgot to plug in s, and this is 7/3 t. Alright, now what we're going to do is we see that our x vector down here, I should really erase those lines, but our x vector, oops, not working, oh well. Our x vector down here, we can see that right here. This is our x vector. So we can set that equal to this side. So let's do that. So we have x1 x2, x3, x4, our x vector, is equal to negative 1/2 s plus 2t, negative 1/2 s plus 7/3 t, s, and t. So these are our equivalent vectors. And now our last step is to factor out the s and t from this vector. So we're going to say that this is s times, we use our s term, we ignore the t terms for now. Well, all the t terms are 0 since we're only looking at the s. So we have 1/2. Remember, s is factored out, so when we multiply s times this, we get negative 1/2 s. And then we have negative 1/2 again. Then we have 1, because 1 times s here. And then t is just 0, right? We're ignoring the t's for now, because the t portion of our linear combination is going to be right here. So now we're looking at the t terms. We have a positive 2t right here, so positive 2. And again, when we multiply this t by the 2, we're going to get 2t at that top term. So our second term, 7/3. And then s, there's no t term, so it's 0. And t times 1 is just 1t. And now this is our null space. Well, these two vectors are our null space. So our null space of A is the span of those two vectors. I'm writing small again. I don't know why. We have plenty of space. I shouldn't be writing small. Alright, that is our null space. And I can put that into step-by-step form for you to make it easier to memorize. So step 1 will be reduced row echelon form. Step 2 is expand your reduced matrix into this X portion here. Expand the matrix A. Step 3 is going to be to isolate the variables and plug in values for x3 and x4, or that's just for this case. Plug in values for your free variables. Step 4 is our last step, and it is to factor out your values for your free variables.